Hey everyone, and welcome. So, we all know the basics, right? Things like get process and get service. They're essential. But today, we're going way beyond that. We're going to uncover some of the PowerShell commands that are practically sysadmin superpowers. These are the tools you use to investigate security, verify file integrity, and take some really decisive action. So let's get started. Look, you probably use PowerShell every single day. But here's the thing, a lot of its most powerful tools are just hiding in plain sight. We're going to skip past the everyday stuff and focus on some specific CMD-lets that solve those complex, real-world problems with, honestly, surprising simplicity. All right, first things first, let's talk about reconnaissance. Before you can really manage a system, you have to understand it. So these first few commands are all about getting the lay of the land, checking out everything from security policies to installed patches. This is a big one, a really critical question for any admin who cares about security. Your antivirus and firewall, absolutely essential. But what about the threats that are designed to target your applications while they're running? How can you actually prove that your core processes are hardened against modern memory-based attacks? Well, this is where get process mitigation comes into play. This commandlet is amazing. It lets you see exactly which security features are protecting a process right now. For instance, it checks for things like DEP, that's data execution prevention, which stops malicious code from running where it shouldn't, and ASLR, address space layout randomization, which kind of shuffles memory around to make it harder for attackers to target. It's like having a direct window into your app's real-time security posture. And using it is incredibly simple. You just run get process mitigation name explorer.ext, and boom, PowerShell gives you this super detailed report. You can instantly see if those crucial security mitigations are turned on or off for that process. It's an immediate security win. Okay, next up, a classic sysadmin task. It's right after Patch Tuesday, you've got to audit a server. So what's the fastest, most accurate way to get a list of every single Windows hotfix that's been installed on that machine? For years, the standard way was using that clunky command get-wimi object class win32_quickfixengineering. And look, it works, but it is so slow. The modern replacement is just beautiful in its simplicity. Get hotfix. That's it. It's faster, the output is way cleaner, and it was literally designed just for this job. If you've got any script still using that old WMI command, this is such an easy and effective upgrade. All right, picture this scenario. You've just downloaded a really critical installer, maybe a server ISO. Before you deploy that across your network, how do you prove it wasn't corrupted during the download? Or even worse, how do you know it wasn't maliciously tampered with? You use a file hash. And guess what? PowerShell has a great built-in tool for this called getFileHash. This commandlet creates a unique digital fingerprint for any file. All you do is compare that hash value to the one the software vendor provides. If they match, you're golden. The file is authentic and unchanged. And using it is super straightforward. You just run getFileHash, give it the file path, and tell it which algorithm to use, like SHA-256. For example, getFileHash path c/iso/winserver.iso, algorithm SHA-256. In just a few seconds, you've got your hash. It's a vital security check you can do without needing any third-party software at all. So, we just replaced that old WMI command for hotfixes. But what about everything else? Getting BIOS info, disk space, operating system details. There's got to be a modern way to query all that system data without having to wrestle with get WMI object every time, right? Yep, there is. Meet getSimInstance. This is the modern, standards-based successor to getWimi object. It's almost always faster, and because it uses the same protocol as PowerShell remoting, it's more efficient and way more firewall-friendly. This should absolutely be your new default for any kind of system inventory query. The syntax is going to feel really familiar too. For instance, just running getSimInstance class name win32_logical disk pulls back all the information about your drives, nice and clean. It's the same kind of query you're used to. It's just built on a much more modern and solid foundation. Okay, so we've investigated our system. Now it's time for phase 2, testing and measuring. This part is all about verifying that your systems and your scripts are healthy, that they're reachable, and that they're performing the way they should be. Ah, man, every scripter has been here. You write a script, it works, but it just feels slow. To make it faster, you first have to find out what is slow. You need a really precise way to time how long each little piece of your code takes to run. PowerShell has the perfect tool for this, measure command. Seriously, just think of it as a built-in stopwatch. You wrap any command or script block inside curly braces and just hand it to the clamlet. So measure command get-event log log name system will tell you exactly how long that query took to run, right down to the millisecond. It's fantastic for optimization. Here's another all too familiar moment. You type enter PS session. You hit the enter key and connection failed. Ugh. Is it the firewall? Is the service not even running? Before you go down that troubleshooting rabbit hole, what you really need is a quick pre-flight check to see if the remote machine is even set up for remoting. That pre-flight check is test WS-man. This command basically sends a little test ping to the machine to verify that the Windows Remote Management Service, that's the engine behind PowerShell remoting, is actually running and accessible. So you just run test WS-man, computer name, server 01. If it comes back without any errors, you know that machine is ready to go for a remote connection. Okay, now for a really critical one for any domain admins out there. In Active Directory, replication health is everything. A silent replication failure can spiral into total authentication chaos. So how do you proactively find these errors before your users start calling and the help desk tickets pile up? The answer is get AD replication failure. Honestly, this command, which comes with the Active Directory module, is an absolute lifesaver. It scans your domain controllers, finds any replication errors, and tells you exactly which servers are failing to sync up and why. Running something like get AD replication failure, scope, site, target, default first site name gives you an instant health report for your entire AD site. So powerful. So we've investigated and we've tested. Now it's time for the final phase, taking action. And the command we're about to cover, well, it's so powerful that using it incorrectly can be truly catastrophic. This one requires more than just caution. It requires absolute 100% certainty. Every sysadmin has fought this battle. I call it the folder from hell. You know the one. It's nested dozens of levels deep, it's full of files with bizarre permissions, and it just refuses to be deleted. You need the ultimate tool to just obliterate it. No questions asked. Okay, before I even say the commands, a very serious warning. This is the definition of a double-edged sword. It is unbelievably effective at deleting things, but it is also completely final and totally irreversible. There is no recycle bin, there is no undo button. You have to be absolutely, positively certain about the path you're pointing it at. The command is remove item, but with two very critical switches, recurse and force. Together, remove item, recurse force, will bypass every confirmation prompt, it'll ignore read-only flags, and it will delete an entire directory tree. It is the absolute final word in deletion. And that power, hidden inside such a common command, is what makes PowerShell so incredible. From the surgical precision of get process mitigation to the brute force of remove item, the right tool is always there. So the real question isn't just what these gems can do for you, but what other hidden gems will you uncover next? How are you going to use them to build a more secure and efficient environment?